Being able to calculate percentages is pretty important. In chemistry, sometimes we'll need to know how much of a given element is in a single compound or how much of one compound is in a mixture. And to do this, we use percentage compositions, usually percentage compositions by mass. And while these might sound like something unfamiliar, they're calculated in exactly the same way as any other percentage you've ever calculated. And I'm going to do 3 different examples now, starting with one that is probably most familiar, calculating a percentage for a grade. So imagine that you had a test and you scored 44 points out of a total of 50 possible points. You're going to calculate the percentage the same way that you learned how to in high school. You're going to take the things that you care about, that is the number of points you scored, and you're going to divide it by the total number of all the things in that sample. So the 50 possible points that you could have scored on the test. And then you're going to multiply that by 100. So the percentage that you scored was 88, 44 points out of a possible 50 times 100. And the units that you include with this are percentages. The second example involves 2 components in a single mixture. The mixture contains 30.10 grams of sugar and 42.06 grams of salt. And we can calculate the percentage composition of that mixture. To do that, we need to find the percentage of sugar in the mixture and the percentage of salt in the mixture. So that's going to involve a couple of different calculations. We'll find the percentage of sugar first. There are 30.10 grams of sugar in the sample. That's the thing that we care about. And we need to know the total of all the things in the sample. That would be the total mass of the sample. So we found that taking the total mass of sugar, dividing it by the total mass of the sample, multiplying by 100, we find that our mixture is 41.71% sugar. And the same method can be used to find the percentage of salt. And we find that the percentage of salt is 58.29%. And if you add up the percentages of sugar and salt, they should come to 100%. One important thing to note here is that when we're talking about a percentage composition of a sample, you need to find the percentage of each component in the sample. So the percentage composition of this mixture includes both the percentage of sugar and the percentage of salt. And our final example is calculating the percentage composition of elements within a formula. So in our example, we'll calculate the percentages of carbon and hydrogen in any given sample of methane. To do that, all we need are the atomic masses of carbon and hydrogen and the molecular weight of methane. So now we have all of the masses that we need. Carbon weighs 12.01, hydrogen weighs 1.01, and methane weighs 16.05. So to find the percentage of carbon, we take the mass of carbon and divide it by the total mass. And the percentage of hydrogen has to be calculated a little bit differently. We can't just take 1.01 grams and divide it by the total mass of methane. There are 4 hydrogens in that sample, so we have to take the mass of 4 hydrogens. And we find that there is 25.17% hydrogen in a random sample of methane.